Hi everyone, welcome back. Thanks for watching my videos. I'm getting a lot of positive comments. Thank you for those comments. In particular, this topic is the area under the curve, which is for Year 12 students or students in their last year of their high school in virtually anywhere in the world. So look at what the topic's about. We're talking about the area under the curve. If you want to watch the other videos I made previously, and by the way, I do playlists on topics everywhere. So if you look for my YouTube page, you can go through and find playlists on trigonometry, equations, decimals, just about any topic you can think about, you can find playlists on it. So I realised I didn't have enough videos on the area under the curve. I had everything on calculus, integrating, differentiating, but I didn't have it on the area under the curve. So I made 3 yesterday, and I'm making a 4th one today. Let's have a look what's going on. Could talk about the basics and what you could do. This is a parabola. For starters, we're talking about a parabola, and hopefully most people realise that a parabola has like a U shape, but in this case it's got this negative here, and that negative means instead of being facing upwards, it's facing downwards. So we've got a parabola that's got that shape. So hopefully if I put a parabola here somewhere, we're trying to find where that parabola passes through the x-axis, because it says calculate the area enclosed by that parabola and the x-axis. Now I'm going to preempt it. If you had a parabola going like that there, you'd know that there's an area in between the parabola and the straight line. So let's have a look at it. Factorisation. I don't want to go too far. I'm going to presume most people know what they're doing. First thing we're talking about is common factor. Now the common factor for all these is we have a negative, and most people have to get that negative out of the way before they can figure out how to do the question. Let's have a look what happened. If that negative's gone to the outside, we're left with a positive. If that negative, that's gone here, now let's have a look at it. If I had a minus 4x, and I could put a 1 there, minus 1 times minus 4x is plus 4x. Now the big one, minus 1, I'm going to just put minus 3 there. Minus 1 times y, minus 3 would be plus 3. So it can't be minus, it has to be a plus. Now hopefully most of you can factorise what's left in here. So the parabolas can factorise normally into 2 factors. Let's have a look what the factors are. This x and that x, if you multiply them out, there's a multiply in between there. Gives us the x squared. How can we get a 3? The only way we can get a 3 is a 1 and a 3 or a 3 and a 1. So I'm going to write the 1 and the 3 in here. And how do we know it's correct? Because the 1 and the 3 adds up to 4. It's like a shortcut to make sure you're correct. If you want to go watch the videos on factorisation, I've got heaps of them. And then we've got, this means that they've got the same sign. I don't want to take too long on this. The plus means that either you've got 2 negatives or you've got 2 positives. And this gives it away that you've got 2 negatives. Now if we checked it, you could have a look and see that minus 1 multiplied by minus 3 would be plus 3. Now this tells us the roots on this graph. So we need the roots to be able to calculate the question, or actually to know how to calculate the question. So the opposite of minus 1 is plus 1. So you can put a root there, or an x-intercept. A lot of people talk about an x-intercept. So one of the x-intercepts is at 1, and the other x-intercept is the opposite of the minus 3, is that one there. Now if you want to go watch my quadratic functions as well, my quadratic equations, there's more on that. Now, next thing, you need more details for the graph. Now I always talk about substitution. I muck around and do this. To get people's brain connected, I'm talking about substitution. What are we going to substitute? If you substitute x equals 0, what happens to the equation? Let's have a look what happens to it. Go back up to here. You'd have the minus of 0 squared. So that's 0. You don't need the minus of 0. Then you got 4 times 0, which is 0. You got the minus 3. Now a lot of people would know when we're getting the y-intercept, you can just go to the constant that's by itself, because that becomes 0 and that becomes 0. So there's the long way of writing that if you didn't understand it. So that means we've got another dot here. Now a lot of people would probably want to figure out for a moment and say, what happened in between? So if we went x equals 2. So this is not about calculating area under the curve. This is all about factorisation and drawing graphs of parabolas. So if I let x equals 2, what would I have? I'd have 2 squared and make it a minus. Remember, that's the 2 gets squared first and then you put the minus on. So that's 4 times 2 is 8. And then you've got minus the 3, and you've got, I always add up the positives first, so it's 8 minus 7, which is 1. So I've got another point here at 2, 1. So if I looked at my graph now, by the way, if you don't know it, all parabolas have symmetry. So if I had a 3 across here, I'd have a 3 across here as well. So there's my parabola. Now I can do the question. Now I can do the integration and the calculations for what's going on. So a lot of people could look at that and go, oh, I've got x-intercepts at 1 and 3, and then they say I want the integral from 1 to 3. Now, just like I spoke about the other day, before people knew about calculus, they could have done it very accurately, drawn it up on a big piece of paper and counted boxes, or made rectangles, the bigger systems to make skinny rectangles out of it. Let's have a look at that. We want the integral from the lowest value to the highest value. So we're going to start the integral at 1, and we want to finish the integral at 3. So we're going to go 1 to 3, and the equation of our graph that we've got here is minus x squared plus 4x minus 3. And then when I put the x, now the x is talking about, apart from being lots of little rectangles, it's also talking about we're using the letter x, or people will say with respect to the letter x. So if I had an equation that was all written in y's, I could have it as do y. And you don't have to have x and y. You can have whatever letters you want. So let's get the integral from that, and I'm going to go to the square boxes, and I'm going to go, what's our rule? The i's, you increase the power by 1, so that 2 has to become a 3. And then you divide by the 3. And that's the process of integration. Let's have a look at the next one. I'm going to bother to do this. The 4x has a 1, so that becomes a 2, and we divide by 2. And the last bit, remember this is really, the first time you've seen me, that's an x to the 0. This x to the 0 is 1. 1 times 3 is 3, or minus 3 in this case. So the 0 becomes a 1, and you divide by 1. Now we could put plus a constant, but we don't need to when we're substituting the values 1 and 3. Now let's have a look what's going on. Substitute the 3, let's be careful with your negatives. 3 cubed is 27, so you've got the minus of 27. I'm going to write it all out on 3. Now what's the trap here? 3 squared is 9. Now you don't actually need, you could have cancelled it out and gotten that to 2 there. It's up to you which way you do it. But that's a 3, 3 is a 9, times 2 is 18, so we've got plus an 18. Now that's also a 3, so that's a minus 9. Now put a bracket in, because when you're subtracting everything, that's going to affect more than the first term, it's going to affect everything. Let's put the 1 back in, let's have a look what we've got here. Bit confusing because I put that there. I'm going to actually rub that off and say 4 over 2 could have been just 2. That's a little bit clearer. So some people will see in their head that if I made that to the 2, and I divided by 2, you end up with just a 2. It does help a little bit. So now we've got minus a 1 cubed, so that's 1 on 3. We've got 1 squared times 2, which is plus 2. And then we've got minus 3 times 1, which is minus 3. And we just have to calculate what that is. I'm going to shortcut a little bit. 3 into 27 is 9, so I've got minus 9. I've got 18 take 9 is plus 9, so interesting part, they eliminate each other. Really interesting. And now I've got the minus of minus 1/3. So careful, that's 1/3. I've got minus 2. And then that becomes a plus 3. And we have to work out what all those numbers are. Good part is they cancel each other out. This is just 3, take 2, which is 1 plus a third. And we've got 1 and a third. So there's the answer to the question. We've got 1 and a third unit squared. Remember, most places can't talk about unit squared. Now do something different that I haven't done on the other videos here. If I turn that just here into a rectangle, so if I went up there, and I went up there, and I went across there, how big would that blue rectangle be? And most people are okay. I hope you think about this, because it's just 2 times 1, which is 2. And you can see that the red area has to be less than 2. And it turned out it was 1 and a third. You can imagine how easily you could calculate that, but there's the accurate answer. You might end up with 1.33 on this, and you realise that it's 1 and a third, but there's the exact answer. Now, for those who aren't okay, I want to do something else. So, let's have a look what's going on here. There are people out there who really struggle with factorisation. I can name some of my ex-students who are now in their 40s or 50s who struggle with factorising that to be able to get that graph. The fail-proof method, I did so many of this back when I was at school, because we didn't have calculators and we didn't have computers. So this is what we had to do. I've seen so many students in the highest level courses and the highest level graphs, and they don't know what to do, and all they had to do was put some values in. So I'm going to start here with 0, 1, 2, 3 and 4. And I'm just going to do what I talk about all the time. I'm just going to be doing substitution. Now, if you can't factorise, or if you're not sure what the graph is, just put the numbers in. So let's have a look at what happened. When I was in school, my math teacher made me write this down. That's 0 squared, so he'd make me write minus 0. That's 4 times 0, which is 0. And that's minus 3. If you add them up, that's a minus 3. So we now know one of the points on this graph is that one there, which is 0, minus 3. So how do you get the next point in the graph? Substitute 1. So you've got 1 squared with a minus. You've got 4 times 1, and you've got minus 3. And the interesting part is with most assessments, there's your 0. We're looking for this point here, which is 1, 0. And you're looking for where it crosses the x-axis, so you know where to start and you know where to finish. And you can see the obvious thing now, most of you wouldn't need it. So the 2 is 2 squared, that's a minus 4. 4 2s are 8, minus 3. And you've got 8 minus 7, so that's 1. So you can see the point there, 2, 1, and you didn't need to factorise. Now the moral of the story of this is, you get some yucky question that you've never seen before, like say 1 over the square root of x plus x, and you go, I've got no idea what that is. There are rules and things I could teach you, which is in a lot of my other videos, but you can simply put in 0, put in 1, put in 2. Now the annoying part for this, if you put in a 2, you'd have the square root of 2, which is horrible. So you look for nice numbers. So let's put in 3, you've got 9 with a minus, you've got 12, you've got minus 3, and we're back to 12 minus 12 is 0, and you can see your whole graph's done. Now if you wanted to, you can go 4 4s are 16, so that's a minus 16, 4 4s are plus 16, then you've got minus 3, and there's your last point here, which is 4 minus 3. So if you can't factorise or you're running out of time because your exam's in 2 days' time, don't forget you can just put the numbers in, see what you get and go from there. So back to the basics, what's going on? We've got a parabola, say you don't know it's a parabola, you can put the values in, get your graph, and it says get the area between the curve or the function or the graph, whatever you want to call it, and the x-axis. And the integral is that exact answer, which is quite amazing. Oh, I hope you found it helpful. Thanks for watching. Bye for now.